Well, hello. We're going to start part 3 of this conditional probability series. I did choose a word problem that was a little long, had lots of words, so I'm hoping it's a good one. So let's jump right into it. So in a survey of 1,000 eligible voters selected at random, it was found that 80 had a college degree. Additionally, it was found that 80% of those who had a college degree voted in the last presidential election, whereas 55% of the people who did not have a college degree voted in the last presidential election. Assuming that the poll is representative of all eligible voters, find the probability that the eligible voter selected at random or had a college degree and voted in the last presidential election. Okay, so we had a lot of words up here. Let's actually go down here and break it down into our notation, our set notation. Okay, so we had a survey of 1,000 eligible voters selected at random. 80 had a college degree. So let's let C have a college degree. That's what we mean by C, college degree, which means C complement, no degree. Okay, so what do we know from that? We know that the probability that you have a college degree, since this is representative of all eligible voters, we had 80 who had a college degree out of 1,000, so 80 out of 1,000. Okay, and we might be, well, let's write that as a decimal. I guess it might make things a little bit easier for us in the future. Oops. Sorry about that, dropped my pen. So we got 0.08. Okay, so what does that mean about the probability of C complement? The probability that you select someone that does not have a college degree. Well, if 80 of them do out of 1,000, then 920 out of 1,000, which is 0.92, do not have a college degree. All right, so that's what we got so far. What else do we know? Additionally, oh, you know what? We haven't said this yet. What are we actually trying to find? All right. Now, we want to know is the probability that they had a college degree and voted. Okay. So what I want is the probability that they have a college degree and they voted. Okay, that's what I want. All right, but we haven't finished writing down all the information we know so far. All right, so clearly C is college and V is going to vote. Okay, but the trick is what does this information right here mean? Found that 80% of those who had a college degree voted. Okay, so what does that mean? In notation form, what that says, okay, is that the probability that they voted given they had a college degree. So it's not just the probability that they voted, it's the probability that they voted given, because again it says of those who had a college degree. So the probability that you voted given you had a college degree is 80%. And then what else does it say? The probability, or no, whereas 55% who did not have a college degree voted. So that means the probability that you voted given you did not have a college degree was 0.55. So based on this, it looks like you were more likely to vote given you had a college degree than if you did not. All right then, so this is all the information we can pull from here. So let me just write all of this up here. Okay, so we're in the conditional probability section, so it's probably assumed we should try using a conditional probability. If you're given conditional probability information, you can use a tree diagram to kind of visualize what's going on. So let's go ahead and do that down here. Okay, so let's set up a big tree diagram. Now, since there are two groups, we know that we're going to have two sets of branches. So we know we're going to go up and down on a branch, and then we're going to have another branch. Now, which one is the first one? Is it college or is it voting? Okay. Now, you got to remember that this branch right here represents some event occurring given that you've already gone up a branch here. So whatever this is going to be, whatever this represents, it's been given that you've already gone up another branch. Well, if you come back up here, what does this say? This is the probability that you voted given you've gone up the college degree branch. So based on this, okay, I'm going to have V here and college here. So this is my college branch, and then this is my voting branch. And it makes sense because all the information they gave you about voting was depended on whether you had a college degree or not. So that makes sense that voting is on the second set of branches. So down here would be not a college degree. This would be voting. Okay, so let's see what we have. Now, by the way, I'm going to erase this in a second, but what this branch represents the probability of a college degree. This branch, which represents the voting branch, but it's specifically the voting branch given you've gone up the college branch. Okay, I'm hoping that makes sense. Okay, so what was the probability that you had a college degree? It was 0.08. What was the probability that you voted given you went up the college branch? I already forgot what that was. 0.8? Yes, 0.8. All right then. Now when you go up these branches, okay, so if you go up this branch and then that branch, what this is telling you is that you went up college and the voting. So in the end, what that represents is the probability that you're college and you voted. All right, so you've gone up the college branch, you've gone up the voting branch, which means you've gone up college and voting. And that's going to be, well, just multiply these two together. So that's going to be the probability of voting given your college times the probability of college. And guess what? Here's our conditional probability formula. Okay. Oh, and look, that's exactly what we were trying to find. Hey, how nice is that? I didn't mean for that to happen. It just did. Okay, well, we have our answers already then. What's the probability of voting given that you're college educated? 0.8. Probability that you're college educated? 0.08. So in your calculator, you'll take 0.8 times 0.08 and 0.064. So as a percentage, that's about 6.4%. Okay. All right, so that's the answer to our first question. But you know what? Before we move on to the second question, let's just figure out how to fill in the rest of this information. Okay. So here, this is the branch for people who did not vote. Okay. Because it doesn't actually tell us anything about that up here. Okay. Nothing in here said about people not voting. But based on the tree diagram, I know that I can figure this out. So this here, this one represents the probability that you did not vote given you're college educated. Now, when you go up your branches, whichever way you go, because we only got two options, they have to add up to 100%. So if we go up here 0.8, which is actually 80%, then the people who did not vote would be 20%, or 0.2. We already know the probability that you are not college educated. That was 0.92. And I shouldn't say college degree. I think they're specific about that. All right, and then they tell us that the probability that you voted given you did not have a college degree was 0.55. Ran out of room there, which makes this one down here 0.45. Okay, so I'm going to copy this, and then we're going to start the next question. All right, so second question. Did not have a college degree and did not vote in the presidential election. Well, I bring up my tree diagram again. Let's pull this down. Do we already have that answer? So what I'm looking for, okay, what I want is the probability that you do not have a college degree and you did not vote. So what this is it's going up the not college degree branch and the not voted branch. That's actually right here. So let's go down the not college degree branch, not voting branch. So we would multiply these two together. Okay. And so that's going to be 0.92 times 0.45. So let's see what we get. And I get, my calculator would work, 0.414. Okay, so there you go. Let's move on to the next question. Okay, next question. This one is a little different. Voted in the last presidential election. So all I'm looking for actually is what is the probability that you voted? That's it, the probability that you voted. Now, without the tree diagram, this actually would be fairly difficult to do. So let me pull up that tree diagram again. All right, and okay. Notice that the voted part is on the second set of branches. That's okay. All right. But if I want to know what's the probability that you voted, I have to figure out all of the branches that count. All right. So which ones count? Well, this one does, right? These are the people who voted. Who else voted? These people. Okay. So if you voted, it means you've gone up this branch or you've gone up this branch. Okay. So that makes things pretty easy. So the probability that you voted has to be the probability that you have a college degree and voted plus, or you could say or, you do not have a college degree and voted. Okay. So in one of the two, either way, you voted. Whether you had a college degree or you didn't, these people voted. So it's the intersection of C and V, which we found already. That was 0.08 times 0.8 plus, and then the probability that you do not have a college degree and you voted. So that's 0.92 times 0.55. So let's see what we get. And I get 0.57. So 57%, since we're actually dealing with 1,000 people, that's 570 people. We know that 570 people voted. All right, so let's see. We got a minute and a half left. See if we can get one more in. Okay. Last question. Had a college degree. So what is the probability that they had a college degree given that they voted? All right, well, that kind of sounds familiar. We had the probability that they voted given they had a college degree. Well, that's not exactly what we're trying to find. Looks like what I want is I want the probability that they had a college degree given that they voted. Okay, well, if you take a look at the tree diagram, where's that at? So the probability that you had a college degree, that's these people. Given that they voted, well, that's weird. It wants us to go backwards. Okay. Well, at this point, you don't know how to do that. Okay. And I chose this problem for this reason. In order to do this, we have to use a theorem called Bayes' theorem. And that's the theorem we're going to learn in the next video or so. So we'll finish this problem when we get to that part of the section or that part of the video series. All right, see you then.